So electric vector is along y-axis, magnetic vector is along z-axis, and propagation is along x-axis. Those waves are called electromagnetic wave. If you hold two pen in your hand, one along y, other along z, then x will be perpendicular to both, na? Hello?
Yes.
I'm just holding pen in my hand. You also hold one pen. Perpendicular to x-axis. If I change the pen, I rotate the pen. In all cases, it will be perpendicular. That plane is perpendicular to x. देखो पहले आप वर्टिकल हॉरिजॉन्टल रखो, रखा, हाथ में रखना बराबर. यस, रखा है.
Yes.
अभी अपने
Yes.
हाथ को रोटेट करो. पेन को मत रोटेट करना, हाथ को रोटेट करो. तो एक्स एक्सिस हॉरिजॉन्टल में ही है ना.
Yes.
एंड वाई इज चेंजिंग द पोजीशन, करेक्ट. बट
Yes,
इट्स स्टिल
sir.
परपेंडिकुलर टू एक्स, करेक्ट और नॉट.
Yes, sir.
नहीं समझ रहा लगता है. दो पेन हाथ में रखा है कि आपने पहला,
Yes, sir.
Yes.
और अभी अपने हाथ को घुमाओ गोल. पेन को मत घुमाना, पेन को जैसा है वैसे ही. क्या लग रहा है आपको, पेन परपेंडिकुलर दिख रहा है क्या?
Yes, sir.
Yes, sir.
और एक्स एक्स पे ही है ना, खाली वाई का पोजीशन चेंज हो रहा है ना. That
Yes.
means electric vector can be in any plane, still it will be perpendicular to the direction of propagation.
Yes, sir.
So when light waves, anybody who has not followed, please ask her, because with that pen only you will understand. Still, if you are not analyzing, shall I start the video and explain you, or you have followed?
Followed.
Okay. So when light waves are obtained due to vibrations of electric vector in any plane perpendicular to the direction of propagation of light waves, then they are said to be as unpolarized light. Write down. When light waves are obtained due to vibration of electric vector in any plane perpendicular to the direction of propagation of light wave, then they are said to be as unpolarized light. हेलो भारत, पाठो दो आता लेक्चर में नहीं पाठो. Written?
Done, sir.
Yes, sir.
Okay. Now see how it is represented. So if I have got one vector vertical along y-axis, other vector inclined but perpendicular, that means plane is inclined. So can I draw that line as vertically upward and inward? मतलब ऐसा, if this is rotated and comes like this, मतलब अंदर जा रहा है, so I can have its component this way and one going inward ना, which I cannot see.
Yes.
देखो अपना पेन हाथ में लो और थोड़ा इंक्लाइन दीवार का तरफ रखो, इंक्लाइन, तो एक कंपोनेंट कैन यू ड्रॉ टू द वॉल एंड सेकंड टू द रूफ अपवर्ड.
Yes.
तो व्हेन यू ड्रॉ टू द वॉल तो ये मुझे डॉट डॉट दिखेगा ना खाली, एंड
Yes.
अलोंग रूफ ऐसा दिखेगा ना. सो दे आर रिप्रेजेंटेड लाइक दिस, vertical and then going inward, unpolarized light wave. This is their representation. Means actually it is vibration of the vector drawn in two component y and going inward z. This is how it is represented. Means actually from the source it is having many direction. We can represent it as it is shown. It is vibrating in many direction and it is represented like this. This is representation of unpolarized light. Unpolarized light. Right. Here you can say vibration in many planes. These are electric vectors. Done. Can I go to the next topic?
Done, sir.
Okay. Polarized light. When vibrations of electric vectors are confined मतलब restricted. When vibrations of electric vectors are confined in only one direction, then the light waves obtained are called as polarized light. They are represented as shown. So either vertical vibration or it is shown inward vibration. These are polarized light. Right now. Right, and then draw the diagram.
Done, sir.
Okay. Plane of vibrations. See, this is unpolarized light having vibration in any direction, which is resolved and made along y and z. Unpolarized light. It is made to pass through a device called polarizer. Mostly it is Nicol prism called as polarizer. From this, when we get, suppose, only this vertical vibration, then this is the plane which contains vibration of electric vector, and this is the plane whose vibration is absorbed or not allowed to pass. So this one is called as plane of vibration, and this is called as plane of polarization. मतलब उसका वाला vibration is absorbed or not allowed. Are they perpendicular to each other?
Yes, sir. Yes.
So plane of vibration means plane containing vibration of electric vector. Plane of polarization is plane which does not contains vibration of electric vector. So just draw the diagram, then both definition are given. The plane containing vibrations of electric vectors is called as plane of polarization. Sorry, plane of vibration. Plane containing vibration of electric vector is called as plane of vibration. Draw diagram and write the definition of plane of vibration which I have written. Yes, completed, I think.
Yes, sir.
Okay. Plane of polarization. The plane which does not contains vibrations of electric vectors is called as plane of polarization. Right. The plane, the note you will write down after that. The plane of vibration and plane of polarization are perpendicular to each other. The angle between direction of propagation and plane of vibration the angle between direction of propagation and plane of vibration is 0. Generally we feel 90-degree, but it is 0.
Answer.
One more line we'll write for this vibration. One more note, third note. The angle between plane of polarization and direction of propagation. See, we are not telling line of vibration, a plane of vibration we are talking about, and direction of propagation is also 0 degree. Written?
Yes.
Okay. State Malus law. State Malus law. What is intensity of light and amplitude relation? Yes. Intensity of light and amplitude. Any relation? It is proportional to square of amplitude. Intensity of light. So if this is one vibration and this is another vibration inside, when you pass it through polarizer, then only one will be left out. One. So earlier, if this is A, then when it comes out, only one A is left out. So in first case, when it is unpolarized, then intensity is root 2 A the whole square, because two vectors are perpendicular, one up, other in, result is root 2, some constant. And when only one comes out, then this polarized will become proportional to only one amplitude square. That means ratio of unpolarized to polarized will be 2A square upon A square. So can I say polarized is half of unpolarized intensity?
Yes.
Okay. So unpolarized light passes through one polarizer, then always the output is half of the original. So if you imagine this is unpolarized light due to vibration of electric vector in many plane. This is one polarizer only allowing this light wave to pass. So we'll get output as, if this is I, then this output will become half of I. Yes, clear? Will it become half of I?
Yes, sir.
Now, if the axis of rotation, axis of vibration is made in this way, that means it is making angle theta with original axis. So we get only A cos theta in vertical direction. This is A.
Yes, sir.
We get only A cos theta traveling. So now intensity will become I equals to A cos theta the whole square. So I will be some constant into A square cos square theta. Correct?
Yes.
That means I is equals to I by 2. Wait a second. Intensity is I square cos square theta. So I resultant is I cos square theta. Therefore, it will be I cos square theta. हेलो, इसका हो गया ना I naught, इसका हो गया ना cos square I naught. So can I say it is nothing but I by 2 cos square theta? This is I naught coming out from here. Are you getting this formula?
Yes, sir.
I naught मतलब मेन वाले का हाफ ना, तो ये जो फॉर्मूला है ना I naught cos square theta, उसको ही मालूस लॉ बोलते हैं. So just copy this, then I'm writing statement.
Sir. Sir, could you explain again that how I not came?
Here, what is vibration?
Zero.
जीरो. जीरो कैसा बोल रहे हैं? एक ऐसा वाइब्रेट हो रहा है, एक इनवर्ट जीरो होगा, दो वेक्टर परपेंडिकुलर है तो
No, sir.
so it will be root of 2 times a. The whole root 2a, two vectors are perpendicular, both are a, so this is intensity of unpolarized. अभी मैं कांस्टेंट निकाल दिया, एक्चुअली प्रोपोर्शनल टू रूट 2a स्क्वायर, मतलब 2a स्क्वायर होएगा.
Yes.
एंड पोलराइज्ड में एक ही एम्पलीट्यूड बाहर आया ये, so it is proportional
got
to a
it, sir.
square. So when you divide, what you will get? I upon 2.
Yes, I got it.
Now if the axis of polarization is making angle theta with original, तो इसका कंपोनेंट आएगा ना, ऐसे वाले को जाने नहीं देगा वो, खाली ऐसा वाले को जाने देने वाला है, वर्टिकल वाले को, तो a cos theta स्क्वायर. क्लियर?
Yes, sir. Clear.
ठीक है. So can I clear this everything now?
Yes, sir.
Okay. When the polarized light is made to pass through an analyzer. पहले वाले को polarizer, second वाले को analyzer. Through analyzer where axis of polarization makes angle theta with axis of polarization of polaroid, मतलब start वाला polarizer, then resultant intensity of light through second polarizer comma I equals to I naught cos square theta. This is known as Malus law. Any doubt in the statement? This I is resultant, not the original. और ये I naught मतलब original वाले का half into cos square theta. Yes, any doubt now?
No, sir.
Copy. Written full?
Yes.
Okay. Angle of polarization. See, when unpolarized light is incident on interface of two medium, then it gets partially reflected and partially refracted. The angle of incidence at which reflected light is completely plane polarized is called as angle of polarization. So angle of incidence itself is angle of polarization, but it is that angle where reflected ray is completely plane polarized. Completely plane polarized means if these are the unpolarized light passing, then after reflection this light will be obtained and this is completely absorbed. तो एक वाला completely मिल रहा है, and refraction में it can be partially unpolarized और थोड़ा polarized मिलता है. That is called, this is called partially polarized. This one is partially polarized and this is completely plane polarized. That angle of incidence is called as angle of polarization. What is angle of polarization? Angle of incidence. What is angle of polarization? Yes, angle of incidence only. But that angle of incidence at which unpolarized light, when incident on plane refracting surface, it gets partially reflected, and reflected wala is completely plane polarized. Clear meaning?
Yes, sir.
The angle of incidence at which when angle of incidence at which when unpolarized light is incident on refracting surface, then it gets partially reflected and partially refracted. Then if reflected light is completely plane polarized, then the angle of incidence is called as angle of polarization. Copy. Called as angle of polarization, in bracket write IP.
Done, sir. Done, sir.
Yeah. State Brevester's law. State Brevester's law. According to Brevester's law, when unpolarized light is incident on refracting surface, then refractive index of medium in bracket mu is tangent of angle of polarization, that is mu equals to tan IP. So whenever you read that light is incident at polarizing angle, remember mu equals to tan IP. If they say the reflected ray is plane polarized, then also mu equal to tan IP. With this one part of the chapter we have completed, that is wave theory. Next part is interference. Together they form wave optics.
Cancer.
Okay. Show that when light is incident at polarizing angle IP, then reflected and refracted rays are perpendicular. Reflected and refracted rays are perpendicular. Light is incident at angle called polarizing angle. Partially it gets reflected and refracted. We have to show that this angle is 90. This we have to prove. So if I call this as A, O, B, this is D, normal as MN, angle made by incident ray with angle by reflected ray with normal is angle of reflection. This is the angle of refraction. I have to prove this angle is 90. This is unpolarized light coming. Here we are getting completely polarized. Here we are having partially polarized. Means both we are getting polarized as well as unpolarized. Just complete the diagram, then we'll see.
So done.
Okay. Let IP be angle of polarization. And R comma R dash the angle of reflection and refraction respectively according to Brevester's law, mu equals to tan of angle of polarization. So sine of angle of incidence upon refraction is sine IP upon cos IP. Now sine I and sine IP are actually same. So I can say sine R dash is cos of angle of polarization. So sine of R dash is sine of 90 minus angle of polarization. But by law of reflection, we know IP is IR. So that will become sine of 90 minus R. Any doubt till this? Yes, any doubt in this? Yeah, please copy till this and
No.
2 more lines.
Done, sir.
See both sides sine. So if it is sine A equal to sine B, can I say A equal to B? We can, na? If sine I, नहीं समझ रहा लगता है. If I write like this, sine A equal to sine B, what you can say? A is B or not?
Yes.
So there sine R dash is equal to sine 90 minus R. So can I say that means R dash is 90 minus R?
Yes.
So that means R plus R dash is 90 or not? Correct, no?
Yes, sir.
Yes, sir.
So from figure, if you see carefully, R plus R dash plus which wala angle is what in that diagram? BOD, na? In that diagram, what is this angle? AOB, ऐसे नाम दिया है ना?
Yes, sir.
And this is D, I have given the name, or C?
B.
Huh? This name what it was given? D or C? What it is just?
D.
This only.
Yes, sir.
So I can say from the figure, this is R dash, and angle BOD, is it 180 degree? Angles forming linear pair.
Yes.
So R plus R dash, we got 90 degree, plus angle BOD, can I say 180 degree? That means
Yes.
angle BOD is 180 degree minus degree 90. So I can say BOD is 90 degree. That is reflected ray and refracted ray are perpendicular. Yeah, complete. So whenever light is incident at polarizing angle, always reflected and refracted ray are perpendicular. So three things you have to remember at polarizing angle. First, you can use Brewster's law. Second, reflected ray is completely plane polarized. Third, reflected, refracted are perpendicular.
Done, sir.
Critical angle. Not to be prepared. Huh? Don't prepare it, but numericals they can ask this. Theory don't prepare. Critical angle, not for 12th. You have done in 11th, so not for 12th. See, if light is incident, or when light travels from rarer medium to denser medium, then it will move away from normal or it will bend towards the normal.
Towards.
It will bend towards, but it travels from denser to rarer, then
Away.
Wait.
away from normal. So if I increase angle of incidence, at certain angle light will come on the surface.
Comes
In
to
that case,
particle.
angle of refraction becomes 90 degree. So that angle of incidence at which angle of refraction is 90 degree is called as critical angle. What is critical angle? When ray of light travels from denser medium. This is important. It should travel from denser medium to rarer medium. Then angle of incidence at which angle of refraction becomes 90 degree is called as critical angle. When ray of light travels from denser medium to rarer medium, then angle of incidence at which angle of refraction becomes 90 degrees called critical angle, right?
Done.
Okay. Just one small thing, then we can stop. Huh? Just small part. Show that refractive index of denser with respect to rarer is 1 upon sine of critical angle. By Snell's law of refraction. What is refractive index of second medium with respect to first? Is it sin I upon sin r?
Yes.
Okay. So in our case, who is second medium, denser or rarer? Rarer, no?
Yes.
Traveling from denser to rarer, second rarer, first denser, will become sine of I upon sine of r. When I becomes critical angle, then what is angle of refraction? 90 degree, na?
90.
Correct. So can I write further refractive index of rarer with respect to denser is sine of critical upon sine 90? So when I take reciprocal, then it will become sine 90 upon sine of C. Okay.
Yes.
So that means 1 upon, when this is nothing but refractive index of, when you interchange, you can write reciprocal as this, na, denser to rarer.
Yes.
That will become sin 90 means 1 upon sin c. So when I interchange this denser to rarer, rarer to denser, then it becomes reciprocal. So denser to rarer, 1 upon sin c. Copy now.
Done, sir.
Okay. So that's all for today. We'll meet in today's extra lecture.